Now I am going to discuss about the oversampling. First method is the random oversampling. In the oversampling, what we used to do? We add some samples in the minority class and make it equal to the majority class. So first method is the random oversampling. Same thing, I am using the pandas data frame method sample. Here B add some samples in a random fashion, right, and make it equal to the majority class. This is the majority class. If you see here, it is, and making equal to the majority class. Same thing whatever we did in the undersampling, same thing I am doing in the oversampling, except changing the minority and the majority variable here. Next method is the random oversampling with imblearn. Here I am using the random sampler method, creating the object, then training our object with the help of input variable, then I am getting this particular output. So if you see here, the output having the same, it means minority class equal to the majority class, and the intuition is same whatever we have in this particular sample. It means in a random fashion it will add the samples in the minority class. Next is the synthetic minority oversampling technique, that is also called as a SMOTE. In this technique, first we select the majority and the minority samples that we have selected. In the second step, we select the nearest neighbor only in the minority, let k is equal to 3. So 1 2 3, this 3 I have selected for this minority classes. Then we add the synthetic point between these two minority classes. Okay, these two minority classes. Okay, here we add. How do we add? So for that, let this is the x1, this is the x2 vector, this is the x3, this is the x4. So I have to add some points here. So let this is the x1. So s1 will also be a vector, so we can say x1 plus, we have to make a difference between these two vectors, x2 minus x1, and we have to multiply with some random number between 0 and 1. So this way we will get the synthetic point. Once we will use the different random number between the 0 and 1. By that we can add some points here. So this is the intuition behind this SMOTE technique. So for that I am gonna import SMOTE method, then creating the object, then training this particular object with the help of this input data, then we get the output, this particular sampled output. These output we can use to train our machine learning model. So this particular SMOTE technique perform better when we have the continuous variable. But if our model will have the continuous and the numerical both variable, it means continuous and the nominal categorical variable, in that case we use this SMOTE-NC. Same thing here, I am going to import this particular method, then creating the object, then training. But one thing here, we have to add the categorical position, it means categorical column index here. Same thing, it will provide me this particular oversampled output. Next method is the Borderline-SMOTE. So in the Borderline-SMOTE method, you can follow this particular paper to understand, but let me explain in more summarized way. This is also a part of the SMOTE method. So what we used to do here, first we select the minority and the majority classes. Let me select it. These are your majority classes, we can say. Okay, these are your majority classes, and these your minority classes, we can say. Okay, So let these are your majority and these are your minority classes. In the second step, what we will do, we will calculate the misclassified point in the minority class. We have to check whether this point is misclassified or not. So how we can check? We have to select the KNN, K nearest neighbor. Let me select 3. So for that we select the 3 nearest neighbor, 1, 2, 3. It means this point is misclassified. Then again we will check this point. If you see here 1, 2, 3, this is also misclassified. 1, 2, 3, this is also misclassified. 1, 2, 3, this is also misclassified. So if you see here, most of the points lie in this particular border area between the positive and the negative points. So that's why it is called as a borderline SMOTE. In the second step, we select the nearest neighbor and select the misclassified minority points. In the third step, we apply the SMOTE. Right, let these are the misclassified point, 1, 2, 3, 4. These are the misclassified point. So we add some synthetic point between these two. These, right? We add some synthetic point here. How do we add? Same way, just like your SMOTE. It means S1 is equal to x1 plus difference between these two vectors, x2 minus x1, then multiply by random variable 0 and 1, right? So this way we can apply the borderline SMOTE. But borderline SMOTE are the two types, borderline SMOTE 1 and borderline SMOTE. So borderline SMOTE 1 is this, whatever I have explained. In the borderline SMOTE 2, there is a little bit difference. In the first step, we select the minority and the majority class. In the second step, we select the misclassified minority points, as we did in this particular borderline SMOTE. But during the misclassified selection, here we only select the minority points, right? We select the minority points and calculate the nearest distance, all the minority points. But in the SMOTE, so what we do here we select k nearest neighbor from both the minority as well as majority. So here by this will be misclassified. Let's check. I calculate the nearest neighbor y in this particular majority. So in that case, this distance, this and this is the misclassified, right? Because this is the misclassified and these are the two nearest neighbor, right? So we will use these 2 points, right? And we will add the synthetic point between here after using the third step SMOTE. Only difference in the third step is that here we are using this particular formula. So here we are using random variable 0 and 1 in this SMOTE 1. In this SMOTE 2, we are using random variable 0 and 0.5, right? Otherwise both are the same. Only difference is that in the first step both are same, okay. In the second step, misclassification step is same, but here we use only minority classes. Here we use minority and majority both the classes to get the nearest neighbor. In the third step, here we use 0 and 1 random variable to multiply the difference. To multiply with the difference, here we use the random variable 0 and 0.5 to multiply with the difference. Otherwise both are the same method. Conceptually both are same. So here same thing, I am gonna import this, then creating the object. Here we have to mention the borderline 1 or borderline 2, then training our model with the help of input, and this will provide me the output. Same thing borderline 2, and this will provide me the output. You see both are the same thing. Then borderline SMOTE SVM. So if you see here we are performing selecting the minority and majority classes, then misclassification, then applying the SMOTE. here what we can do here in the SVM, here if you see here in the Borderline-SMOTE, we use the KNN, right? But here we use the support vector mechanism to misclassify the positive and the negative points with the help of this particular SVM, right? Otherwise both are the same things. We use the support vector mechanism to get the misclassified point near the border. So those points we will use, and then we will apply SMOTE. Then we will apply this SMOTE to add the synthetic point. Otherwise both are the same. Only here we use the support vector to get the misclassified point. Then here in the Python, just importing, then creating the object, then training our model with the help of input variable these. Then we get this particular output. Next is the KMeansSMOTE. In the KMeansSMOTE, here we use the clustering mechanism. It means first step is the cluster the entire input using k-means. Let these are the data points I have. Okay, and these are your minority points. Okay, these are the minority and these are your majority points. So here we create the cluster. How do we create the cluster? First cluster is that, second is this, third is this, fourth is this, fifth is this. I created these cluster. Then what we used to do, right, here we check which cluster has the sparsity in the minority class. Here we have 4, here we have 4, but here we have 3. So here we have some sparse minority classes. So we will add some minority classes in this cluster. Also add some here, right? So this way we use the k-mean clustering mechanism to add the synthetic point. And how do we add? The add mechanism same as SMOTE, just like addition between these vectors. So for that I am gonna import this KMeansSMOTE method. Then what I am doing, I have to apply the k-mean clustering to select the cluster. So for that first I am gonna creating our this particular standard scalar. It means if you see here, my output is not in a stand. If you see here, there is a large variance in the data set, right? This will have a different variance, this will have a different variance, this also have a different variance. This will also, if you see here, distribution of the data is different in all the column. That's why I'm gonna use the standard scalar here, so that my column will come in a same scale. Then I am selecting the how many cluster I should use, right? So that's why I am gonna use this. So we can use 2 clusters, right? If you see here, elbow mechanism, so I can use 2 cluster. Same thing, I am using this part creating the object. In the object I am using the minority strategy. Then k-mean estimator is equal to 2. It means I am using 2 cluster. Then cluster balance threshold, how we can make a balance. So for that I am using 0.2 and density it is R2. So after that I have to train our model with the help of input variable. This will provide me this particular output. So this way we can apply the KMeansSMOTE. So now we are going to discuss about the oversampling with adaptive synthetic sampling. So what we used to do in this sampling, let's check this particular data set I have. These your majority classes and these are the minority classes. So what we used to do, we calculate the k nearest distance between the minority classes. Let k nearest distance between the 3 nearest neighbor for all the minority classes. So those minority classes which have the least distance, those will not be count. Let this particular minority class, this will have the more distance as compared to this sample, right? So this particular sample will be count. If you see here this, if you see here this, right? So if you see here, if you see the density around this particular point is very less, and the density here is large because the distance is very less. It means there are lots of minority points. Here is also lots of minority points, but here we have very less points. So what we used to do, we add these samples here by using this SMOTE. It means where the density is low, we add the synthetic point with the help of SMOTE. That is the intuition behind this particular method. Now how do we perform? Same thing, we will import, then we will create the object, then we will apply the fit method. It means we will train our model with the help of xtrain and bytrain. This will be your sampled output. Now we are gonna create the logistic regression model before oversampling, right? We see a recall is very less, F1 score is very less. Now precision recall is also very less, precision recall AUC curve. Now I'm gonna apply the oversampling dataset, creating the object, then training our model with the help of oversampled dataset. It means KMeansSMOTE. Now I am calculating the performance matrix. If you see here, I am getting the recall 86. Here I am getting only 20. Now I am getting 86. And F1 score is 26. Here I am getting 29. It means F1 score is decreased. It means it is not performing well with the oversampled data. So that's why we always try different techniques in the machine learning. Machine learning, just like we can say it in trial method. We always try different technique, and which technique will provide me the good performance matrix, that technique we use. But AUC, if you see here, it is better as compared to this particular 27, right? So we can use different performance matrix to evaluate our model performance. Now third thing, we are gonna use the oversampling. It means combination of the oversampling and undersampling. Here I am using the SMOTE and TOMAC link. For that I am gonna import this particular SMOTE TOMAC method. Same thing, creating object, then applying the train and test fit method, which will train our model. Same thing, combination of the SMOTE and add it nearest neighbor. So this way we can perform the different sampling technique to make the classes balance with the help of oversampling, undersampling, and the combination of the oversampling and undersampling method. Now second method, we can use resampling technique using the right performance matrix. As I told you, if you see here, if we are using the accuracy, right? If you see here, if we are using the accuracy, I am getting 96. If we will only consider the accuracy, then we will select this particular model without resampling, right? But whatever the model we are creating, we have to understand that here our main aim is to detect the defaulters. So we will consider the recall should be as much high as possible. Also precision should be high. Also F1 score should be high. So we have to select the correct performance matrix, right, to deal with the imbalanced data set. That is we are gonna tell here. Third one is the resampling technique using the penalized algorithm or the cost sensitive training. It means whenever we use the different classification based algorithm, there is some parameter which by using that we can try to provide some weightage to the classes. It means 0 and 1 classes. Let's see how we can do that. Here if you see here, I am using support vector classifier. If you see here, there is a one parameter, class weight equal to balance. It means it will try to make balance between the both the classes 0 and 1, right? Balance means 50-50%. Let's check how does it work. Let's check 0 and 1. 0 has 10 and this has 100. It means we have 1/10 ratio. So what it will do, it will provide 0, it means 0 class weight is to, we can say 10, and 1 class weight is to So how does it work? Let's 0 class B have 100 samples and 1 class B have 10 samples. So here class weight would be 0 will be equal to 10, okay, and 1 equal to 100. This type of the weight mechanism. It means it will provide more weightage to one class and try to make a balancing between the classes. If we will use this particular inbuilt method, inbuilt parameter, then if you see here, my F1 score is improved a little bit. Also accuracy score is also improved. Let's check the logistic regression. In the logistic regression, here I am using 0 for the 1 and 1 for the 10. It means minority class I am providing the more weightage. So here you can see I am getting F1 score 0.14. ROC AUC I am getting little bit more. So what we can do? We can use this particular class weightage mechanism, also the oversampling or the undersampling. It means we can make a customized model. First we will do the oversampling or undersampling. On top of that we can use this particular class weight parameter so that we can improve our model performance. And the other method is the collect more data. So that is the best way. If it is possible to collect more data, that would be more beneficial, and that we can use to train our machine learning model. And also we can apply the undersampling if we have more and more data. Treat the problem as an anomaly detection, right? We can use the different anomaly detection technique to make the classes balance. And the model based, here we are using the logistic regression model. Might be the different model can perform better with the imbalanced data set, like the random forest. If you see here I am applying the random forest, I am getting the F1 score better 38, and with the help of, if you will check the ROC AUC curve and the precision recall curve, you will get the better, right, 38. And here I am using the XGBoost, here I am getting the F1 score 40. It is very good as compared to the logistic regression, right? So this way we can use the different classification algorithm which can perform better with the imbalanced data set. Now here I am gonna use the cross validation, which I have already discussed in the initial starting of the video, that we can perform the model training in a two way. First one, we can directly use train test, then we will do the sampling, then that train and test we can use to train our model. And once we create our model, that model we can evaluate with the help of unsampled data. Now we are going to discuss about the how we can use the cross validation with the sampling. So as I have already discussed in the starting of the video, that we can train our model in a two way. This is our data set, okay, then we do the train and test split. This is the train and this is the test, okay. Then we train our model, and then model will be evaluated with the help of this test data, and then we do the prediction. That is the normal. Second approach is that we do the sampling here, right? After sampling we train our model, and then this is the unsampled data to evaluate our model performance. This is the first approach. Second is that we use the cross validation. In the cross validation we can also perform in two ways. First, we can directly use the sample data, and then we do the cross validation on top of this particular sample data. Another one is that we use the cross validation with sampling. It means during the cross validation we also do the sampling parallelly, right? Here in the sequence, first sampling, then cross validation. Here cross validation and sampling simultaneously. Let's see how we can perform these two things. So if you see here, first I am creating the sampling. It means I have created my sampled X train and Y train. After that I will apply the cross validation. If you see here I created one pipeline. In the pipeline, first I am using the scaling our data set, then classifying. It means which classifier I will use, logistic regression. Then which CV method I will use, stratified k-fold. Then I am gonna use grid search mechanism to get the best parameter. Estimator I will use this particular pipeline. If you see in the pipeline, I am using logistic regression and the scaling. So this method will have this particular thing. Then parameter grid. In the parameter grid, which parameter I am gonna use? This particular C. In the, we can also call it the lambda. And scoring method I am using F1, and CV I am using stratified fold, and number of the job is equal to -1. Here I am doing the cross validation. Okay, then I am doing the grid search. Grid search, because this is I am using grid search. Okay, so grid search here, after here I am training our model with the help of this particular sample data. Sampled we have already done, right? Sampling we have already done. It means we are performing grid search on top of sampling. Then we are testing the score of the grid search. So this way I am getting 90 and 30.25. Now what I am doing, I am applying grid search with sampling. If you see here in the pipeline, I am applying grid search simultaneously. Earlier we have already done the sampling, but here this sampling I am performing in the pipeline during the cross validation, right? So if you see here in the SMOTE, then scalar, then classifier, then we will do the grid search. This will simultaneously perform the cross validation and the sampling, which means train our model with the help of these xtrain and bytrain. So this way we can apply the cross validation to train our machine learning model. So what are the advantages of the oversampling? Advantage is that of the oversampling, no, here we will not have the information loss in the oversampling because we are adding the more samples. And disadvantage is that sometimes it may cause the overfitting. So what is the advantage of the undersampling? Advantage is that if we have a very large data set, like millions of the records we have, then we will perform the undersampling, and by using the undersampling we can reduce the data size, and then we will perform the training. Our training time will be reduced. And what are the disadvantages? Disadvantage is that we may lose the information. If we have a very less data set and then we perform the undersampling, in that case there will be the data loss. So today we have discussed how we can handle the imbalanced data set, where I have covered almost all of the technique.